Hello. Today we're going to talk about simple sequential games where everybody knows everything. In the game in front of you, player 1 goes first. We start up here, and player 1 picks A or B. Player 2 observes what player 1 did, and then player 2 moves. If player 1 picked A, player 2 can pick F or G, whereas if player 1 picked B, player 2 can pick L or M. After player 2 moves, we get to what's called a terminal node, and each player gets his or her payoff. So if 1 picks A and 2 picks F, we end up here, and player 1 gets 7, and player 2 gets 3. Now the goal of each player is to maximize his or her payoff. You're not trying to beat the other person. In fact, you're completely indifferent as to what happens to the other person. Why don't you pause this video and try to guess what you think will happen. Okay. Here's what I think will happen. Now, player 1 has a difficult decision because player 1 can't figure out what he wants to do until he guesses what player 2 is going to do. But player 2 has a really easy decision to make. If player 2 is here, his decision comes down to which number is bigger, 6 or 3. And if player 2 is here, his decision comes down to whether 9 or 6 is bigger. So we can say if player 2 ends up here, and player 2 is rational, he'll pick G. Whereas if player 2 ends up here and player 2 is rational, he'll pick L. Now the next step is that player 1 will realize what player 2 will do. So player 1 will realize that if he picks A, player 2 will pick G, and if he picks B, player 2 will pick L. So player 1 will think A leads to G, which leads to 0 for him, whereas B leads to L, which leads to 5. So player 1 will pick B, and then the parties will end up here with player 1 getting 5 and player 2 getting 9. Now, I still think when solving this game, it's important to circle this G. Player 2 never gets here, so G is never played, but one of the reasons player 1 picked B was because of the expectation that if A is played, it would lead to G and 0 as opposed to F and 7. So when solving these games, again, I think it's important to circle what will happen at every point where a player gets to make a decision. Okay, let's consider another game. Now, instead of labeling them player 1 and player 2, I've labeled Tim and Bill. But in terms of the payoff, Tim, since he moves first, he gets the first number, whereas Bill gets the second number. Okay, why don't you pause this video and figure out what's going to happen. Let's look at the solution I came up with. So again, it's always easiest to solve these games backwards. Because again, for Tim to figure out what he's going to do, he's got to guess what Bill has to do. But Bill doesn't have to worry about that. Because if Bill is here, he says, well, I get to pick M, which is 6, or L, which is 5. 6 being bigger than 5, I'm going with M. If Bill ends up here, he'll say, well, I get to choose between 4 and 15. I'd much rather have 15. So I'll pick Z. Now Tim recognizes that Bill is rational. Tim will say A leads to M, which leads to 7. B would lead to Z, which leads to 6. Since 7 is greater than 6, Tim will pick A. The parties will end up right here. But again, it's important when solving this game to circle this Z, because part of the reason Tim picked A is because of his expectation of what Bill would have done had he picked B. Let's go to a slightly more complicated game. Now, in this game, Sam, who's player 1, can pick A, B, or C. If Sam picks C, the game is over. Judy never gets to move. If Sam picks A, Judy has 3 choices, where if Sam picks B, Judy has 2 choices. Again, please pause the video and guess what you think will happen. Okay. So I'm guessing that Sam's going to end up picking C and Judy never moves. But the reason is because of what Judy would have done had she moved. If Sam picked A, Judy has a very simple decision. She gets to pick 3, 5, or 7. She'll go with 7 because a rational player maximizes her payoff, and in game theory, the default assumption is everyone's rational. So Sam will figure A will lead to H, which leads to 7. If Sam were to pick B, Sam would figure, well, Judy, if I pick B, would get to choose between 70 and 50. Well, duh, 70 is bigger than 50. So B would lead to X, which would lead to 70 for Judy, but only 12 for Sam. So now Sam will say A would lead to H, which would lead to 8 for me. B would lead to X, which would lead to 12 for me. But C leads to 13. 13 being bigger than 12 or 8, Sam will pick C. But again, it's important to circle this H and this X because they're part of the justification for why Sam picks C. Okay, let's do still a more complicated game. Now, in this game, a player might move twice. So player 1 would move. If player 1 picks A, player 2 is here. Player 2 could end the game, or player 2 could pick J, which would cause player 1 to move again. So again, please pause this video, figure out what happened, and try to figure out what happens at every single decision node. All right. So it's always easiest to solve backwards from these games. To solve, you start at places where a player, when he moves, the game will end after his move. The difficulty in game theory is for when I don't know what I want to do till I figure out what you want to do. So we eliminate that difficulty by finding places where I no longer have to care what you're going to do because the game will end. So if the parties reach here, if player 1 gets to be here, player 1 will say, well, I now can pick D and get 5 or E and pick 8. I'm going to pick 8. If player 2 ever gets here, player 2 will say, well, I have a choice between 11 and 3. I'm going with 11. I would pick K. And if player 1 ever ends up here, player 1 would say, well, my choice is between 4 and 0. I'm going with 4, and I'll pick F. Now we can move the next level up. We can say, well, player 2, if he gets here, we'll know that J would lead to E, which would lead for player 2 to 9, and that beats anything else player 2 can get once he's here. Then we move up here, and player 2 will say, well, N, we've already figured out, would lead to F, which would lead to 7. My other two choices would give me 5 or 3, so I'll go with N. So now we know enough to solve the game and figure out what player 1 will do in the beginning. Player 1 would say, well, A would lead to J, which would lead to E, which would lead to 8. B would lead to K, which would lead to 6. C would lead to N, would lead to F, which would lead to 4. Well, 8 is the best of those, so player 1 would pick A, and this is how the game will go. The parties will march this way, but again, still important to circle what would happen here, here, and here, because what happens in that part of the game tree, that influenced why the parties ended up here. Okay, let's do a final game for this video, and now this is a very simple 3-player game. So now player 1 moves, and if player 1 picks A, then player 2 gets to move. But if player 1 picks B, player 3 gets to move. And then, after player 2 or player 3 moves, the game ends. Obviously, the first number goes to player 1, the second to player 2, and the third to player 3. Please pause the video and figure out what you think will happen. If you're not actually doing that, and it seems obvious, you're probably not getting much out of these. These games, once you see the solution, it might seem obvious, but that certainly doesn't mean that you're capable of solving it if you hadn't seen the solution. You really don't want to have the first time you try to solve these games for real to be on an exam. You'll, chances are, do very poorly. All right, here's what I think will happen. Again, player 1 has the difficulty of not knowing what he wants to do until he figures out what someone else will do. But if player 2 ends up here, player 2 no longer has to worry about anyone else and would say, well, L leads 6 for me, M leads 1. 6 is better than 1, so if player 2 ends up here, he's going with L. Player 3 would say, well, if I get to move and I end up here, my choices are X, which is 6 for me, and Y, which is 3 for me. 6 is bigger than 3. I'm going with X. Finally, player 1 would say A leads to L, leads to 5 for me. B leads to X, leads to 8 for me. Since 8 is a bigger number than 5, I'm going with B, and this is the way the parties will march down the decision tree, but what happened here still matters. Thank you very much.